plant-based materials gain ground in beauty sector. As industries face increasing pressure to reduce emissions and rethink resource use, attention is shifting from energy systems alone to the materials that underpin everyday products. Japan-based Green Science Alliance is advancing a broad strategy aimed at replacing petroleum-derived inputs with plant-based alternatives, an effort that spans far beyond any single product category. The company's work is grounded in the premise that plant-derived materials can offer a more balanced carbon profile over their life cycle, as the carbon released at end of life is partially offset by carbon absorbed during growth. While the concept of carbon neutrality in biomass remains debated depending on sourcing and processing, it continues to gain traction as organizations look for pathways to reduce dependence on fossil-based feedstocks. Under the direction of CEO Ryohei Mori, the company has been developing a wide range of bio-based materials, including biodegradable plastics, resins, coatings, adhesives, inks, and even structural applications such as 3D printed furniture. The scope of this portfolio reflects an ambition to replicate conventional material performance using renewable inputs, positioning biomaterials not as niche alternatives, but as scalable replacements across multiple industries. From lab to consumer, cosmetics as a testbed. While much of the biomaterials conversation has centered on industrial and packaging applications, consumer-facing products are emerging as an early proving ground. In this context, Green Science Alliance has introduced a series of plant-based nail cosmetic products, including biodegradable nail tips, water-based polishes, and solvent alternatives, all designed to demonstrate how renewable materials can function in performance-sensitive applications. The company's latest development, a plant biomass-based nail adhesive, illustrates how this broader strategy is beginning to translate into commercially viable products. The glue, which cures under UV or LED light, aligns with existing application methods in the nail care market, requiring minimal behavioral change for users. With a reported biomass content of 22 to 30%, the formulation represents a partial but incremental shift toward renewable inputs. Rather than positioning the adhesive as a standalone innovation, it serves as a case study in how plant-based materials can be integrated into complete product systems. When paired with the company's biodegradable nail tips and other components, the result is a more cohesive bio-derived offering, highlighting the importance of compatibility across materials in driving adoption. Balancing sustainability claims with performance reality. As with many emerging material alternatives, the long-term viability of plant-based formulations will depend on their ability to meet established performance standards. In the case of nail adhesives, this includes factors such as bonding strength, curing time, durability, and user safety, areas where traditional cyanoacrylate-based products have set a high bar. The company suggests that its plant-based adhesive may offer advantages in user experience, particularly in moderating the rapid chemical reactions associated with conventional glues that can generate heat and, in some cases, cause irritation. By adjusting reaction dynamics, the formulation aims to reduce these effects while maintaining functional performance. However, broader market validation will likely be required to determine whether these benefits hold under widespread use. From a business perspective, the development underscores both the opportunity and the complexity of scaling biomaterials. Supply chain consistency, cost competitiveness, and regulatory alignment will all play a role in determining adoption across sectors. At the same time, growing consumer awareness around ingredient safety and environmental impact may create new demand signals that favor such innovations. In that sense, the nail adhesive is less an endpoint than an early indicator of how material innovation is evolving, moving from concept to commercialization in targeted applications, while pointing toward a larger transition in how products are designed, sourced, and evaluated.